So as we continue here into 3.9, proving lines parallel, for all intents and purposes, this is really a repeat of the previous sections. Just because Tennessee has removed proofs from its course curriculum, so we're just going to be able to, just thinking about these things and understanding the definitions that we've gone over is where we really want to focus. Okay, so identifying parallel lines. The converse. Converse statements, we really didn't talk about those, but just thinking about being able to move back and forth in our definitions. For example, before, we're talking about corresponding angles, and they said that if we had two parallel lines cut by a transversal, right, so this is probably like B and this is T, cut off. If we have parallel lines A and B cut by transversal T, then my corresponding angles are congruent, which is angle 4 and angle 2 are corresponding. And we've learned that already. Well, what they're doing here is they're just going to flip that around and they're going to say, hey, if two lines are cut by a transversal so that the corresponding angles are congruent, now they're saying if those angles are congruent, then we have parallel lines. So they're just moving forward and back through the theorem. So that's what we're doing here in this converse. So instead of saying if I have two parallel lines cut by a transversal, the corresponding angles are congruent, they're saying, hey, if you got two lines cut by a transversal and the corresponding angles are congruent, then they're parallel. Okay, that's what they're talking about there. Same thing here with the converse for the alternate exterior. If I have two parallel lines or two lines cut by a transversal and the alternate exterior angles are congruent, then they are parallel lines. So that's what they're doing here on all these converse statements. We've already learned what alternate exterior angles are: consecutive interior angles, alternate interior angles. A perpendicular transverse, basically saying it intersects at 90 degrees. So that's what they're doing here. So in practice, it's really the same stuff we've been doing. So here it says, give the information to determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. Okay. Again, if angle 2 and angle 8 are congruent, they are alternate interior angles, interior in between A and B, and they are alternating on line M. So that would be the alternate interior angles. If they are congruent, then we have two lines are parallel, and this is simply by the alternate interior angles converse. Okay, so that's all they're saying. And we're not going to have to define this, but we're just trying to understand those definitions and theorems and think about how we can use them. Here on angle 3 and 11, if you notice, angle 3 and angle 11 are actually in corresponding locations because the two lines, line L and line M, would be cut by transversal A. So 3 and 11 are in corresponding locations. They are corresponding angles. Corresponding angles of lines L and M, and because they are the same, L and M are then parallel by the corresponding angles, the converse. Let's see here in 12 and 14. 12 and 14 are going to be alternate exterior angles. Here's my transversal, and they are on opposite sides, which makes them alternate. They are outside of my two lines, so alternate exterior angles. They are outside of lines A and B, and they're the same, so they're going to be the alternate exterior angles converse. So just understanding, if those alternate exterior angles are congruent, then we have two parallel lines. Okay, just being able to make that identification. Okay, so here, check. Given the information, determine which lines, if any, are parallel. All right, 1 and 15. What do we know about 1 and 15? Angle 1 and angle 15. Are they on the same transversal? Are they over? They're not on the same transversal. So what I'm going to say here is there is not enough information for us to be able to make that determination. Something along the line, they have to give us some more information. We just can't go straight over there. They would have to give us something like a corresponding. 1 and 5 are corresponding angles, then 5 and 15 would be alternate exterior. So they just didn't give us enough. Didn't give us enough to work with here. 3 and 10, measurement of angle 3 plus 10 is at 180 degrees. Okay, if 3 and 10 equals 180 degrees, then this and this should be parallel because those would be the same side, right? I think I said sometimes we call it the same side or consecutive interior angles, converse. But just recognizing what the relationship is between 3 and 10. 3 and 5, let's see. 3 and 5, if you think about where are angles 3 and 5, they are alternate because the transversal would be line in, so they're alternate, they're interior angles. So if they are the same, that would mean alternate interior angles are converse. So alternate interior angles. Now, there's two answers here. So which two lines would be parallel? The lines that would be parallel would be L and M because those are the lines they're interior to. So it looks like A. A is my answer. Okay, so moving on again, now we start doing some information here that what values of Y would allow lines E and F to be parallel. Find the value of Y, so E and F. E is parallel to F. If that were the case, if those were parallel, then these two could be corresponding angles, which would mean they would be 90 degrees. And if they were 90 degrees, then this would also be equal to 90 degrees. So I can say that 4y plus 10 is equal to 90 degrees, and I can do my inverse operations. And 80 is equal to 4y divided by 4. So if y is 20 degrees, then we have parallel lines. That's all we're doing here is what value of y. If it's anything other than 20, then those lines would not be parallel. So here, find the values of x so that m is parallel to n. Identify the postular theorem. Well, let's just think about it. If this line is parallel to this line, these two locations are corresponding angles. So if they're parallel, the corresponding angles should be equal to each other. If they're equal to each other, then that gives us proof that the lines are parallel. So you just make them equal to each other. I got 6x minus 3 is equal to 2x plus 1. Do your inverse operations, right? Subtract 2x from both sides. I got 4x minus 3 is equal to 1. Add 3 to both sides, and then 4x equals 4 divided by 4, and x is equal to 1. So if x equals to 1, then these two corresponding angles would be congruent, and that would be the corresponding angles converse. Okay, but that's what we're looking at. Those would be corresponding, and I just start working with that. Now, here it says find the measure of LMN. So we're looking for this measurement right here, this angle, so that A and B are parallel. Okay, A and B are parallel. So I want this line to be parallel with this line, and if that were the case, I could probably look at this and this are alternate exterior angles. And if my alternate exterior angles are congruent, then I have parallel lines A and B. So simply, I have 9x minus 12 is equal to 4x plus 6. Again, inverse operation. Subtract 4x from both sides because I'm combining like terms. 5x minus 12 is equal to 6 plus 12. 5x equals 18. Divide both sides by 5, the coefficient, and x is equal to, I don't know that we necessarily need to simplify that out. I'm just going to say 18 over 5 for right now. And so this is the angle I'm trying to find. So angle LMN would be 4 times 18 divided by 18 over 5 plus 6, which is 72 over 5 plus 6, which I believe, you think about it, this is, this number right here is about 14.4 plus 6 is going to give me 20.4 degrees. So there you go. We could plug that information in and find out what the actual measurement of the angle is. So again, we are using the same kind of information we were working with yesterday. Let's see here. Looking at this. To move, let's see here in this example, to move in a straight line with maximum efficiency, rowers' oars should be parallel. Refer to the photo at the right. Is it possible to prove that any of the oars are parallel? Justify your answer. Well, if I look at this, I can see that I got 124 here, and if I have this straight line, and then I have a linear pair here, this angle here should be 180 degrees minus 124, which would make that equal to 56 degrees. Okay. Now, if this was a parallel, if these were two lines cut by a transversal, then this angle measurement right here corresponds to this angle right here. Well, if they were parallel lines, this should also be equal to 56 degrees. And it's not. Okay, it's 50 degrees. So those two are not, the oars are not parallel right now. So that is, so this is, and they did it the other way, and they said this is 130 degrees. The angle measure, 130 degrees, is the blank angle to the corresponding angle to the top angle. But it is not possible to prove, either way you look at this, it is not possible. This is not the same as this is not the same as this linear pair, so the corresponding angles don't match, are not congruent. And then really here, probably going to do the same thing with this word problem. Is it possible to prove the support poles of the antenna complex are parallel? All right, let's see. Again, if they're parallel, if I have this parallel and these two lines are parallel, then you got to think about these two angles are my consecutive interior angles, or same side interior angles, and they should be equal to 180 degrees, but in this case, these only equal 174 degrees. So they are not equal. So I know that I have a no. They are not parallel lines because that does not equal 180 degrees. No, because of consecutive interior angles. Or no, because of alternate interior angles. Well, we know that they're not alternate interior angles. They're consecutive interior angles. And they did not add up to 180 degrees, so they are not supplementary. So there you go. That's just using that information that we've been learning and continuing on with examining images, thinking about those properties and those theorems and what makes them match our definitions. So with that, we're going to continue on.